In this video, we're going to look at topic 68, example 4, where we write a system of equations as a matrix. The main question is, how can a matrix represent a system of linear equations? And in part A, we're asked, how can you represent, they give us two equations, using a matrix. So first off, what is a matrix? Well, a matrix is a rectangular array of values. To use a matrix to represent a linear system of equations, the equations must first be written in standard form. So standard form is ax plus by equals c. All right, so we need to make sure that all of our equations are in standard form before we can actually write a matrix. So if I take the first equation, 3y equals 1 minus 2x, what I'm going to need to do is add 2x to each side so that I now have 2x plus 3y is equal to 1. That's in standard form, so now we can work with that. The second equation, 4x equals 10 plus 2y. This time I'm going to move the y variable, or the y term. I'm going to subtract it, so I get 4x minus 2y is equal to 10. Again, this is an ax plus by equals c, so this checks out. There's two different types of matrices that you're going to see. You have a coefficient matrix and you have an augmented matrix. Coefficient matrix shows the coefficients of the variables in the system of equations. So in this case, I have the equations 2x plus 3y equals 1 and 4x minus 2y is equal to 10. And in a coefficient matrix, all we're concerned with are the coefficients. Right, that's why it's called a coefficient matrix. So we have these four numbers here. So my matrix, I would take those numbers, 2, 3, 4, and negative 2. So that's where each of these numbers is coming from. And that's my coefficient matrix. All right, that's it. You just take the coefficients and you write them as a matrix. It could be a 2 by 2, it could be 3 by 3, it could be all different sizes, but here we're dealing with a 2 by 2 matrix because we have two equations, two variables. Now, an augmented matrix shows all coefficients end, all right, so end constants in the system of equations. A dotted line separates the variable terms from the constant terms. So I'm going to rewrite my equations. I'm going to use my same colors here. In an augmented matrix, so we still have our coefficients, so it's still 2, 3, 4, and negative 2. So that doesn't change. They come over just as they did before. However, this time, we also need the constants. And the constants are separated by a dotted line. Now, let's use this green and purple, perfect number. So if I bring this 1 over and this 10 over, and the bracket will close off that matrix, there's really no way to tell, all right, what's a coefficient, what's a constant term. So what you do is you just place a dotted line to separate basically where your equal signs are. All right, so instead of the equal sign, you have that dotted line, and that is your augmented matrix. It's just a different way to write a system of equations, and you'll find in the next section, I believe, why this actually becomes quite useful. Makes it much easier to type into a calculator, and there's a lot of different things we can do using matrices rather than writing them out kind of algebraically. And again, we'll get into that and you'll see what's going on there. So let's look at part B. In part B, how can you represent the system of equations of 3 variables and 3 equations with the matrix? Right, so here we're going to try to come up with some type of matrix here. Usually you're going to use an augmented matrix, so let's stick with that. But I'm going to rewrite these equations. They're mostly in standard form. Notice that I left a little space there, and I'll point out why that is in a minute. So x minus y plus 3z Notice that that first equation does not have a z term. It means we can't ignore it, but there is something we can do. So there's something missing right here. So just be careful with that. I'm going to put ones in here just to remind myself that there's ones. We do need to put those in. So in this matrix, there's actually going to be three terms, right? Because we have three equations. So I'm going to take the numbers here. That's going to be a 1, 2. They should be in alphabetical order, so it should be X, Y, Z. The second one here, I would have 1, -1, and 3. And then finally here, here I would take the 2, +1, -4. Now do notice that that Z term is missing. We need to fill that in. That wasn't supposed to happen. We do need to fill that in, so there needs to be a 0 there. All right, think of it as a placeholder. So these three numbers get matched up from there. Shouldn't be too bad. And we do want to write our coefficients in. So I do need to show this 2, 5, and 10 here because I need to show the entire system. If I don't show the constants, what they're equal to, then I don't really have the whole system being displayed in the matrix. So I'm going to put my dotted line, and then here we want our constants. Right? And you wouldn't actually write these words or these letters up here. I'm just showing you where they're coming from. So we would have 2, 5, and 10. And that is our augmented matrix to represent that system of inequalities. Just be careful with any missing ones, and do really, really make sure that you're careful that you have them in alphabetical order. So X, Y, Z. Occasionally, books like to throw them in different orders, or they like to skip ones, like in this case, Z was missing in that equation. So just be careful with that. You really shouldn't have too much difficulty writing a system of equations as some type of matrix, whether it's an augmented matrix or a coefficient matrix. Should be pretty straightforward. That's it.